Hello, hello. How's it going, everybody? Starting a couple minutes later here. I need to. This music is loud. No, I think I broke it. I don't. My headset is just giving me troubles the past couple of days. Yeah, starting a couple minutes later. What can you do? Things are still a little bit in flux because we built a new computer a few streams ago, and you know, that's just how things go. All right, why is it because this is very okay? It was just a very red screen. This is probably part of it. I don't know how I'm going to deal with that. The lighting is affected very much by the monitors, which is sort of annoying, but I might just need to turn up all the lighting everywhere. But I've also taken out lights because I put it in the computer. There's too many things to do. But I think I got streamer.bot and the chat working again, fingers crossed. No mic issues, fingers crossed. I think I fixed all that right before this stream, so I don't know, we'll see. Anyways, I just noticed my buttons aren't working. That's annoying. Should I fix it real quick? Sure, why not? We're not doing anything with Volt today. I just pulled that up because I needed a white page. How am I OBS? No, not OBS. It's streamer.bot. So we set this up a while ago now? I don't remember. And it actually doesn't seem like it's turned on right now, which is sort of annoying. It is connected to YouTube. But you're all the events, yeah, okay. It didn't connect all the events. So chat message should go to chat event. There's also commands, which I don't remember where those go. So, chat might not actually work. I'm curious if this command though works though, because this is sort of relevant. Oh, they're turned off. That would also explain it. Okay, we'll see if that turns them on. Can you see the loading up in the corner? It might not actually make the connection. We might just roll this off again. I thought I could get it all set up before the stream, but the import and export is not. Guess what I would hope it would be? It's okay though. It's okay. So, why this is somewhat relevant is we're gonna just turn this off right now. No chat. Shrug. The thing that we're gonna do today is WGPU, as you might have noticed. We haven't really done any of that on stream before. So it's a little bit of a new territory, and we're gonna probably be a little bit more on the experimental side today, which is fine. And what WGPU does is it's a group of Rust crates that allow you to write graphics, graphic shaders, I guess maybe is the best way to say it. And those that code that you create, you have multiple like targets or places you can run it in. Primarily, it's going to be desktop and browser. The browser used to be WebGL, and you could write shaders in WSGL, no, WGSL. We're going to be looking these up, so like I'm probably going to prove myself wrong in a couple minutes here. One of the newer APIs is WebGPU, which WGPU can also compile to. And then on the desktop side, it also can do like graphics like you'd see like in video games, so it can target DirectX, Vulkan, Metal, which are common graphics APIs. I suspect we're going to stick more on the browser side, because I kind of want to do stuff on stream, and what we have done previously on stream was use React 3 Fiber. We did those live last year, I guess. We had a bunch of 3D models in Blender, pulled them into a React 3 Fiber scene using GLTF, which is a file format that you can import with helpers from React 3 Fiber. And we hooked up a command, which apparently still is not working, that drops a whole bunch of 3D models that we did on the stream. So I think what we're going to do today is look at WGPU, and we're going to see kind of see how far we can get. There are few WGPU is sort of a lower level crate that ends up being used in a bunch of like Bevy is a game engine. Oh, that's kind of nifty. And an N-body sim. Interesting. I don't know that I've actually been on their doc site, or at least not since they did this. Open the street map. Okay, I'm gonna be distracted for a little bit because some of these are pretty cool. I'm going to assume that most of these are not actually something that we can run in the browser. Which is a little bit unfortunate, but cool. So what we're going to do is we're going to see how far we can get, and we're going to specifically be looking at WebGL and potentially WebGPU. We have the options, and I think the thing that I would kind of like to get to is getting something in a browser source that we can view, and then that potentially be, or excuse me, get something in the, or that we can view in the browser that I could use in a browser source that we could have here. Like, so this background here, I need to like rotate my monitor because I got a little bit of glare. So hopefully I don't. That's fine. Viewing angles are odd. These like hexagon pattern, I don't mind it, but I kind of want to replace it with like a moving Veroni type thing. It's less noticeable here, but I think it'll be much more visible here, which will be fun. So let's kind of dig into it. I don't have anything even really started with either. I've been doing a lot of development on my Mac lately. So I made this computer, and most of my setup and all my coding that I've done has actually been on stream. I think my audio is duplicated. Really? Good God. What's making you say you think it's duplicated? I'm not seeing... Unless it's sending more than one track. That could be. That could be. No, it's sending audio track 1. And y'all should be getting audience mix, which is everything. Can hear my PC fans and my voice is echoey. You know what? You know what? I wonder if it's using the wrong mic. Audience, no, no. I feel like ever since I built this new computer, my audio setup is just frustrating is maybe the best way to describe it. Also, you're welcome, Tony. Thanks for stopping by, and thanks for mentioning something. I don't know that I actually said your name out loud. Brandanovich? Is those? That's one word, right? Is that like one name? Anyways, thanks for stopping by. Definitely seeing you around the Tari sphere. Brendan. Okay, I thought so, but I didn't want to. I know some people prefer the aliases, people don't. That's why I always would just prefer to ask. Okay, so echoey. Why echoey? Why would it be echoey? Is so I don't hear anything. Let's pause the music. It's not easy to talk to myself either. Monitoring audio is hard. I wonder why it's sounding echoey to y'all. Audio is something that seems reasonable. Y'all are getting the whole background here today. Audio track 1. I've got Beacon Mix Create, which does routing, and unfortunately their app does not. I guess that it's weird scaling. Y'all are getting the audience mix. you should only be getting that one. Because I'm only sending my camera audio was recording. Son of a gun. Better? Thank you for mentioning something. Okay. That was a frustrating thing. You know, to be honest, I think I noticed it last stream. And like, I think my audio, I assumed it was some issue with my audio chain because I was having issues. And yeah, it turns out I was misplacing blame that time. Okay, so we should be just strictly, let me just double check. We should be only sending, we're gonna turn all this stuff off. All of this should be going through my audio routing. We only need these three. Are you filming for a video or two? Say more? So I do these streams live. I've mostly only done live. I want to do more video, but I don't think I'm actually going to use this video content. You will be able to see the stream after the fact live. Or not like live, but like there we go. This was way dark. You will be able to like see the VOD, but I'm not going to cut it up and turn it into video or anything like that. But the things that we learn on video, the intention, once I can get all of this stuff all squared away and I'm not messing around with computer settings anymore. Intention is that I use the content and the things that we learn on stream in an actual video. Some of this might end up becoming B-roll, so I am actually recording things. So I can like pull it in and like show parts of the stream, or you know, make like YouTube shorts or whatever. But the intention is that I'm not going to use it directly as like the A roll, I guess, to use the kind of technical term. But we haven't gotten that far yet. Baby steps, baby steps. Yeah, I hear. So okay, so it's actually really cool today. Oh, thank you. Sometimes I have them. So Tony, the reason this is a topic is here. We're gonna go down the path a little bit here. Tari is built of where would be the best place to show this? Let's go to GitHub. Tari is sort of the main thing, like the wrapper piece that does all the like building and bundling and gives you the invoke to talk back and forth. But as part of that, we have a combination of Tau and Rai. Tau is windowing. That's the thing that makes the Chrome or the part around your app. And Rai is the actual web view component within that window. Now, Tau was originally, I guess it doesn't specifically say, but Tau was originally a fork of Winit because the things that we wanted in Winit were not matching up with Winit, so it made sense to just split off. But like, you know, we maybe at some point that'll change. You know, we've as a team we've made contributions upstream to, well, it's not really upstream anymore, but we've made contributions to Winit, and so it's not, there's no animosity. It's just the goal or the scope that we were trying to hit with Tau wasn't matching up with what it wanted to achieve. So tau is the windowing. There's also a plugin with eGUI. Now, eGUI is an immediate mode GUI library for Rust. That means that it's not necessarily using, well, it's not using a web view. So when you use something like this, you're not the window that's containing eGUI does not have a web view. But stick with me here. eGUI also supports multiple frameworks. This is primarily I'm looking for where they say it's a GUI library, an immediate mode GUI library. So it doesn't do the window. So it needs integrations to handle some of that the other pieces to actually make a full app that somebody can use. Now, you can see WinIt is one of the options here. Officially supported. They also use Glow to do, I think that was wasm last time we looked. Also Gleam, but that's deprecated. And you can see here we got a third-party integration to our eGUI. So my curiosity is around, I've been interested in digging into this more and more for a couple of years now. But something that I thought would be interesting would be to the expressiveness that you have with CSS is sort of unmatched. You can look at, like, this is Qt. OBS uses Qt version 5, I believe. Doesn't look bad. But like the ability and just the way CSS works and the amount of effort and things that support CSS is very large. So much so that it like upends all the abilities that you could actually, or all of the like flexibility that you could do on the desktop. So something that I've been really interested in is what does it look like if we could do some sort of like combination of multiple things within the same window. Something with that idea. There's issues with the run loop and whatnot. I don't know if it'll actually come to fruition, but like I think part of this, what we're going to look at today and what might be potentially rolled into a video is how do these like low level pieces within Tari fit together, and why have we made some of the choices that we've made, and are there other options? So like with the eGUI integration, last I checked, the main window opened up, or the main window that you create with Tari had a web view. You could open up secondary windows that were just eGUI. So like that's something interesting too, is something to explore. So you could do something like a game launcher, which is the web view, and then a secondary window that opens up that is a game. But also something I've been interested in is if you could layer those in some way, it would be cool to do UI, like game UI, or parts of the game or something like that with CSS. There are I feel like I've got a couple friends that Chris Piscardi has stopped by the stream a bunch. They have been doing a bunch with Bevy, and Bevy is actually just mentioned it before. It's a game engine, and there's a lot of like crossover of like this. I believe uses WGPU, and I think it uses WinIt for the Windows. I think those like combinations of things is really interesting, and what's makes Tari unique in general is the the ability to do things in the web view, but also have like that backend air quotes there written in Rust, where you could pull in any theoretically any crate. So to your question or suggestion, Tony, this is all kind of leading into that, where what does WGPU do, and what does it look like, and is it something that we could use within Tori? And what's really interesting about the Rust ecosystem in general, the way they do crates and like the composability of the crates, I think it's much more flexible and maintainable than something like relying strictly on like Node.js runtime. That's not really like, I use Node on in my day job. No knock on Node. It has its use cases and it does the job. But Rust is just fundamentally different, different language, different architecture of the language. So, appreciate each for what they are. Nothing is a, I can't remember who said this, but I love this quote. Silver bullets are for werewolf-shaped problems. I love that quote. I think I heard Jason Langsdorff say it first. Shout out to them as well. Let's do some shout outs. Why not? They stream on Twitch. They've got some fun streams. Jason's a good guy. And then Chris does, he has a personal website too, which I think is linked on Rust Adventure. Is this it? Rust? I can never remember. Yeah, I got it right. First time. Hi, Chris. And if you're interested in more WGPU content, Chris is, like I said, he's done a bunch with Bevy, and also does links. Huh. Does he really not have any? He doesn't actually have like any outlinks. I think it's Chris. Whoop, I forgot a D in there.
WebGPU support was merged into Bevy's main branch.
Does that come through?
And will be available in Bevy 0.11. But what is WebGPU?
Cool. I wasn't sure if I had the audio actually working with it. Cool. Yeah, if you're interested in, like, literally just made a video on Bevy and WebGPU. Kind of coincidence that we're working on today, but I actually watched that last night. So, anyways, shoutouts. Complete. WGPU. So, yeah, you're welcome, Tony. Thanks for stopping by. Be here next week. Let's try something out. There is, what would be the best way? Ooh, live demos. I'm actually curious if I have it. Oh, seems like it's working. They only run on Firefox or Chrome Canary with experimental, but I think the caveat here is that WebGPU has actually landed in the main version of Chrome, which is why it works, because this is a very fresh install of Chrome. Not saying evergreen, whatever. But I haven't like done any flags or anything like that, so I wouldn't have turned on the flags for this. So I'm pretty sure it's landed in the main branch. So they point to docs.rs for our docs, which this is good for an API reference. I don't personally feel like that's something that I want to go to understand like how to use it. I mean, I'm partial to the way that we do it in Tori. Guides are valuable. API docs are also valuable. I could buff this up too. So, you know, that would be nice. I don't know if we're actually going to go through this. There is, and I think Chris actually went through these maybe 9 months ago or something like that. There's this Learn WGPU, which is sort of a guide. And I'm tempted to say that it might be, this might be the easiest way to like just run through something quick. I'm not 100% certain like how up to date it is though. So that okay, last updated. Okay. There might be new things since. So WGPU is version 16. If we look at okay, so 15. So we might not really have any issues. I would kind of like to have a small thing that I could copy and paste, and unfortunately, from what I remember watching Chris go through this, there's a lot of code. I mean, some of it is just like this necessity. It's a little bit of a lower level library, which means you kind of end up having more boilerplate. Like the helper or the libraries built on top of these things like Bevy abstracts a bunch of this type of stuff away, which is why you can get away with less code, because it handles more of that like boilerplate and setup. So what if we go? I'm curious in is there something like we can no, this doesn't see like this doesn't look like something that we could just like grab. My personal preference is creating GIFs. Oh, interesting. WGPU without a window. Huh. Anyways, my personal preference is a combination of like, give me the code, show me an example, like give me a GitHub repo or something like that, and then the tutorial sort of like walks through and like shows you or talks you through the entry points into that code. That's seeing how all those pieces fit together. That's how I tend to learn the best. So we may end up using a combination of this stuff. They do mention WebAssembly, so we could potentially just run through a bunch of these, see if we can get something set up. Speaking of something set up, apparently I'm not even sent in. I think Christopher, he's his full name for GitHub, if I recall correctly. I think he did. Yeah. So like, we might actually be able to get away with copying some of this, which I'm kind of okay with, honestly. Yeah, see, this is what I mean. We're, 700 odd lines into actually creating a thing. This looks like it's the wasm stuff. There's state. The run loop. So run is async. I believe it uses Tokyo. And when it, we get an event loop. This might be familiar with I don't know if this is specifically a windowing thing. New event loop. Where's event loop come from? Winit, yeah, okay. So when you create a window, it's got the event loop, and that's sort of like the main thread. So you might recognize this if you're familiar with Tori at all. We get this like build a program or builder API where you build up like that Tari instance, and that's what is controlling the run loop. So window event, you might have seen some of these similar window events when you're working with Tori and cameras. So they don't really have any do they have examples in this folder? That's the other thing that I want to look at. Oop. Repository. Sometimes here. WGPU examples. There we go. How are we doing on time? So we've kind of gone back and forth through a whole bunch of stuff. I think we're probably ended up, at least on this stream, looking through the examples and seeing what we can do with them and see what they look like. So I guess maybe I just let's clone this. GFX-RS. So the way I do my folder structure, I have a like dev folder, and then I have /github / a name, and then the actual repository, which, as you might notice, matches up with that, and I can use Starship RS to adjust my prompt and say anytime I'm in the GitHub folder, change this to like a URL looking thing, and then this becomes something I can like copy and paste. So go ahead and grab that, and we can run them using cargo run that. List of examples. Hey, I didn't even notice that. We scroll down a little bit. So we have features. Water. Ooh. I'm not sure which is going to be. I'm not sure which is going to be a good one to look at to start off with. Closity. Okay, so we got Rust analyzer going. Now, what's fun about a new computer I think, what did I call the last stream? Computer Go Burr? I can't quite point to it. Rust Analyzer there, anytime it would kick in on my last computer. Let's just say I specifically set the process priority for OBS. So it always was like main loop basically. And I can hear my fans actually kicking up just a little bit. So it is doing a bunch of compiling. I definitely have a little bit of a reverberation in there too. I need to like open it up and play around with a couple of screws. I think I know where it is. Yeah. It handles this stuff so much better than my last computer, which feels so nice. All right, let's pick an example to run. We're gonna look at the code and sorry, I'm looking at the fan noise. Actually, doesn't sound too bad. Doesn't sound too bad. Okay. Which one should we do? Lots of these actually don't like mean much to me. I've done 3D modeling work. I've got some background in it, but like I haven't actually gotten to this level to where like sub-resource views. I mean, I understand those words. It doesn't speak anything to me though. And I recognize like Boyd's, MSA. I recognize a bunch of these things, but like Skybox. Let's try this vertex attributes, and we'll go from there. Oh, there's a water. Wait, what? Oh, I'm reading it backwards. I'm reading it backwards. Ah, okay. Yeah, but I'm reading it backwards. So feature the heading here. That lines up with the actual examples. I was reading it the opposite direction. And then they've got a couple of special ones that are just specifically for without using any helping code. Okay. So I'm guessing most of these are going to be using windowing, and we're going to see like windows open up, which is fine. And we can see interesting. Is GLES3. So I think this is specifically for the like back end or the desktop. Like what it supports. So these are, if you've played any video games and like mucked around with the graphics settings, those might be familiar words. DX12, DX11, and you can see if you're a Mac user, Metal and or Vulkan might be a familiar term. But they don't specify. Oh, there's a. Oh, interesting. And on top of WebGPU on wasm. Okay. It's just interesting that it's not in the supported platforms. So, like, what I would specifically like to try to do is I would like to run something that has WebGPU in it. Let's just start off. Let's run a couple examples and just see what they look like. So if we do cargo run example Okay. What's this hello? Let's just try a hello compute. 1, 2, 3, 4. I have no idea what it's gonna do. Okay, so we've got all right. Run examples on the web. See wiki article. And it does serve it. Okay. So these might be actually something that we can look at. This simple example did a game window injection thing, I guess. Now, oh, run wasm. That sounds familiar. What's run wasm do? It's an API which allows you to easily execute code via WebAssembly based programming languages. Interesting. Now, I don't know if I wonder if run wasm is something that I need to install. I don't think that's a command that comes out of the box. So as of, oh, actually a while ago. So we can say specifically use WebSys unstable APIs. Man, I guess my mic is actually doing pretty good on. I can hear that one fan rattle. I think I've got it actually screwed in too tight. I'm surprised it's not picking it up on the mic though. Take it. Okay, so serving cube. We've got we have it served at, oh go. Oh, I don't want to look at that right now. Local host 8,000. Okay. So that is just this like specifically static rendered thing. So we're seeing cube. What does water look like? Let's do water. My thinking here is that, well, partly I'm interested in just playing around with stuff. Does it re-render every time I refresh? Doesn't look like it. So we're getting an image. Let's close some of these windows here. Okay, so we get. Oh, it does create a shader. Interesting. Oh, interesting. Could be used for taking a screenshot. Interesting. So you might notice that some of these actually do line up with, and this actually makes a lot of sense. If we look at live demos and go here, this is what we're looking at. Okay, so woof. That would be a heck of a background, eh? Oh, okay. And this one actually does react to mouse, which is not something I'm specifically keen on needing. I think this is more in the vein of like something that would be valuable to look at and understand. And this is why I kind of prefer this method, because there's a specific thing that I have in mind. I know it can do a lot of, it's great, it can do a lot. I have a specific thing in mind that I want to use it for. If I can find an example that's very close to it, I am comfortable reading this code. I don't necessarily need something that walks me through this. I have a general idea of like how these things fit together. And I don't know that I need all this like background setting it up, walking me through how you configure everything. Not saying that this isn't valuable. I just don't think it's going to get me quickly to where I would like to be relative to looking at this directly. So let's go ahead and actually run this one. I don't know if we're going to be able to, if the goal here is to get something that I can put in a browser source, I don't know that the browser sources in OBS are on a new enough version of Chromium embedded to have this, to even have the flag, let alone be on a version that supports it. Oh. So this is what's interesting. This is running, and the error that is throwing, as I understand it, the reason that WebGPU exists and has become a new thing is that to do WebGL, you sort of needed the helper libraries on top of it to make it reasonable to use. And the things that it does and the capabilities that it does are, I don't know, when did WebGL come out? I mean, WebGL 2 release date? Is that gonna work? So the initial release of WebGL is more than a decade old. What are we in 2023? So almost 6 years old for the stable release of WebGL 2. So there's a combination of a couple things where, like, I think the part of the intention is to make WebGPU easier to write, but also it's got more, the API surface is larger, it can do more. So when you're running something with WGPU, you can write code that in the transformation makes it applicable to either WGPU or to WebGL. But if you're using one of the APIs that's newer and isn't supported in WebGL, it won't be able to down level it. It's not going to be able to take that code and put it in something WebGL that is able to run. You have to run it in WebGPU. So, all of that being said, we should be able to, running it this way, I think, is running it in WebGL. We want to be able to run it in WebGPU. So if we do this, I wonder if this doc is wiki, I guess. I wonder if this wiki is actually up to date. We need to take off the features WGPL. Would WebGL? Wow. Let's see if we get anything else. I'm looking at that compiling here. Naga is another thing. I was actually talking to Chris last night, and they said that Naga is one of the like lower level libraries that that WGPU uses. If we're specifically interested in writing shaders, potentially that might be a way we can write shaders in Rust and have them checked and then compile them out to something that we can like use in OBS. Okay, let's try running that. There we go. Okay, so now this is running in WebGPU. I always have to think about it because WGPU and WebGPU are very similar. This is running a WebGPU, and that's why we're not getting the down level error. So I think this is something we could potentially work with. And now let's, what do we got? We've been going for about an hour. We have two WGSL files. So WGSL is the like shader language, WebGPU shading language. There's also a I said this at the beginning, and I said I was gonna correct myself if I was wrong here, and I can't remember if I was right or wrong, but not that it matters. WGSL is the new here, actually they say right here. Here you go. WGSL is the new shading language for WebGPU. GLSL is the shading language for WebGL. Now, if we're doing something in OBS, let's see if we can pull it up. I don't remember what it supports. So if I look at filters, I might not have user defined. No, it doesn't look like I have that plugin installed. Okay, let's have a slight tangent here and look at OBS user defined shader filter. Don't think that's what we want. I feel like there was something that we're already at the end of our results. I feel like there's a plugin that Exceldro made. If you are unfamiliar with OBS and that, just the like streaming ecosystem, Exceldro is a person that does a lot of yeah, look at that. I spelled it wrong and they were already correcting me. Yeah, Exceldro. Here we go. Yeah. I think this is it. So they've done a whole bunch of plugins, and they're always really well done. They do a great job. But I want to see what format it accepts. So there's examples. Here, user defined shader. Okay, that can be entered. Okay, OBS shaders are written in OBS version of HLSL, so that is different than the WGSL, which isn't the end of the world. They are very similar. Yeah. So we are like in the distraction zone today here. I did say it was going to be a little bit more experimental though, so I'm not feeling so bad about being continually distracted. Naga can do HLSL. There is a little bit of tweaking and whatnot that it specifically says in an OBS version. So there's a way you can do like so they have using this syntax, you can basically enable like through this plugin specifically, I believe, you can enable sliders in different widgets to actually like change the values, so we can make it dynamic. So that's something that would like we could, with a chat command or something like that, we can make the shaders on the screen dynamic, which would be real fun to do. But I would like to try HLSL through Naga. That might be a future stream. Add that one to the list of streams to do. Okay, come back out of our rabbit hole here. Whoa, they're grouping together now. Boyd's has a draw WGSL and a compute WGSL. Again, WGSL is the WebGPU shader language. And that's why... Is that why I can't down convert? Like, what if we go to the water? Okay, so this is also WGSL. So potentially, depending on what APIs it uses, not 100% certain how it works, but I'm presuming that based on whatever APIs it uses without maybe the WGSL, that's why we're getting the runtime error, because it tries to run that WGSL file and it doesn't support it. If we look at let's look at the networking tab. So this is running using wasm. So we get a JavaScript file. This looks in the vein of like wasm bindgen. Don't quote me on that. But if I had to guess, and a lot of what this code is doing is it's a way, it's setting up the way to like load and run the wasm, but also having there's helpers to like make the conversions between wasm and JavaScript. Yeah, here you go, wasm bindgen. So what we end up getting if we run this, we're gonna get a wasm file, which is like WebAssembly. That's what so wasm is WebAssembly, WASM. It's interesting that the line numbers are like, it's kind of cool. No way I'm writing that by hand. Well, we get those two files when we write using our code using this WGPU, and it this helper file is basically just loading the JS, which then loads the that wasm file. So if we go back to this example, here's the down level stuff. Let's make this a little bit bigger here. Down level capabilities. So this is where we were like getting that error. I don't know if, do you actually have, just out of curiosity, unsafe? No. If you're unfamiliar with Rust, unsafe is a keyword. What are these called? Keywords? Or reserved reserved variable, reserved word, whatever. Unsafe is a thing that you can use in Rust to specify that this code, or this little chunk of code, is something that we're not going to be able to rely on the Rust compiler to help us check. And unsafe is the signifier that me, as a developer writing the code, I need to understand and handle those situations that the compiler would normally help me with. It's not necessarily that the code is bad. There are situations where, especially when you're like interfacing with libraries, like you're interfacing with C libraries or something like that, it's very difficult to write code that has no unsafe. That's a whole topic on its own, but I presume we were getting the error from the required download level capabilities. So I'm actually a little bit curious how, like, what ends up being a runtime error. So clearly we got a runtime error. Like, is that going to be the only runtime error that we see? Okay, so here we're loading the shaders. We get the compute and the draw shader. Let's open up these two shaders on the side here and draw. So draw is a pretty small one. And it seems like it's mostly concerned about the position of the particle. So as it's moving around, the positioning of that. The compute so if we look at like these things moving around, they actually end up sort of grouping together. It seems like there's layers too. Like some of them collide and some of them don't. And like they have a note of mass and velocity. So I'm assuming that there's some expectation that like these things can collide. And then we've got some code around like the distance of it moving around and whatnot. Okay. So the actual like shader is relatively split out. So if we were looking to do something like a Veroni, I can never remember how to say it. This. And it has a bunch of use cases which are really interesting. Not that I'm going to get into that today. But like just the layout of it and whatnot is really interesting. So it's like based on points. So as we move the points around, these shapes are not going to be like consistently triangles that are just moving around. They're going to like reform, which is real interesting. And I think that could provide a neat texture. And some programs actually just have them like built in. It's a very, as I understand it, a very common what's the word? It's sort of a math thing, I think, right? It's very common diagram, maybe is the best way to say it. But if we do how to pronounce it, help me out, Google here. Veroni with a short O sound like the O and or. Veroni. Noise and Veroni. Okay. I think I got it right after it. When I was trying to spell it out, I think I was saying it wrong before. But I really have trouble remembering how to say that. Which is gonna be awkward if I'm using it everywhere. But I'm here for it. Veroni shader toy. So this kind of thing would be really neat to do. And there's really not much going on. So if we have a shader, like we could potentially work off of something like this. And for the most part, it's just importing these shaders and then doing stuff with it, I'm presuming. So we have a render pipeline, we have a compute pipeline. Now, as I understand it, in GPU land, I guess I would say, it works off of pipelines where you do a thing and then you pipe it into the next thing and you pipe it into the next thing. And that's where the term pipeline comes into play, I believe. Some of this stuff is very new to me, so definitely don't take my word for it. But as I understand it, that's sort of the background for the terminology. So you have like a compute pipeline. Can we see it being further used? Okay, so we've got a bunch of pipelines and buffers. Yeah, compute and then render. So you're like piping these things together. Resize, render passes, and then we can have it, the test is to output it to a PNG, which is kind of cool. I don't see render doing anything too much here. Color attachments. So I think most of like what we would want to do would be we load our shaders, buffer for simulation parameters, sim parameter data. So they use this to as like a foundation to create a buffer. And then they set up a compute pipeline. So WGPU, find group layout entry. And so it's using that buffer, number of particles. So it looks like it is doing two layouts. So we're getting kind of two layers, and that I think that's what we were seeing. This seems like a lot, and it seems like it's not necessarily two layers, but I think as we like would go back and forth and come back to it, you can see things start to gather. It seems like there's two layers. Oh, that's really kind of cool. It seems like there's two layers here, and you can see some of these particles like pass underneath each other. But some of them collide, like that one right there. Zoom in. Will that work? Yeah. Nice. So you can see like some of those are like crossing over each other, but some of them like right here are running into each other. And I think what we're observing is we have multiple layouts that are on top of each other. TBD on what this actually does though, if I'm understanding that correctly. So then we get a layout, we have a render pipeline, and then we do more, we have a layout for the render pipeline, and then we create a render pipeline. Layout, vertex, fragment, our buffers, seems like they just kind of create them from scratch. I'm not quite sure. There's a draw shader. So this is a little bit less obvious to me just off the bat what it's. I mean, obviously it's rendering. It's a thing that's doing the rendering, but it's a little bit less obvious, like what all these pieces end up doing. And if like we would want to play around with and shift stuff around, like what's that gonna look like here? So doing stuff with the data. Two bind groups. So they got two buffers, it looks like, basically before and after. And that is what ends up dictating the movement. And then it returns the example. So render is called on each frame. Dispatching compute groups proportional. And compute pass, render pass, frame count. So basically they end up in the render, they have a frame, they set the frame number, divide by 2. I wonder why they do that. So basically what they're doing is on every frame, they're incrementing a frame counter. So like we started at 0, we're just going to count to infinity, I assume. It is going to, on each frame, recalculate and recompute everything and re-render everything. So every frame ends up being basically a picture, and that's where you get frames per second. So like in TVs might be well, so this is actually a little bit more involved. TVs and monitors have hertz, and that dictates like the draw cycle, the redraw cycle. So there's the two ends of it. There's the how fast can your screen like redraw itself, but also like how fast can your GPU push out a new frame to actually be rendered. And to get a good experience, there's some value in knowing one versus the other and making sure that you're pushing out enough frames that you always have new things to render if we're going to have a cycle, like a refresh cycle of the monitor. So generally having the FPS a little bit higher or at whatever your monitor refresh ends up being is good for games. The higher the refresh of the monitor, assuming you can push out enough frames for it, the better experience you're going to have. So literally every frame we get a new picture. So if we have 60 frames per second, we are creating 60 pictures every second, and each one of those pictures ends up being sent to the screen and rendered. And it ends up being like one of those flip books, you know? If maybe I'm dating myself a little bit here, but back in my day, you draw like in a book, and I don't know if they actually still do cartoons this way, but they used to. They would draw a frame, and then they would draw the exact same frame again, but with just a little bit of movement. and you stack a whole bunch of those together, and slight movements every frame ends up being the thing that tricks your eye into seeing the actual motion that's happening. So even though like it's just things moving around, like pixels being adjusted on the screen, your brain perceives it as movement because it's happening those such small fine adjustments are happening in a way that are basically faster than your brain. I mean, we're getting to the point where it's faster than your brain can actually like see or process. Which I think the number is pretty high. So I think your eyes can see something like 400 or 500, but we perceive something as having motion at like 20 something, which is partly why the low end, the low side of frames per second on like TVs and TV shows and movies and whatnot has been like 24 and then 24/30. That's sort of like the low end of where there's enough frames there that it allows us to perceive what we're seeing as motion. So basically, what we end up doing is every frame we re-render. That frame then ends up being like input into these computes. Which, do we have a queue spawner self? Do we end up using the frame number anywhere? Okay, just in the vertex buffer. Render pass, compute pass. Got it. Okay. So we're basically every frame we're redrawing and we're using like the frame number as a part of those variables that are like helping to. It's not really helping, but like as input to recompute and change what's actually rendered so it looks like things are moving. So the maybe the lowest level test, the thing that would be maybe easiest to understand or perceive would be that if you had a particle and a frame number starting from 0, if your compute had it every frame move over 1 pixel, so basically like on your screen pixel are 0 to 1920 or however big your monitor is, every frame. So if we're on like frame 30, go to render at pixel 30. Basically, you'd see a thing move all the way across the screen pretty quickly, because you would see it go 30 frames every second. So it would be across your screen in quick math here, but like 8-10 seconds, something like that, depending on how big your monitor is. Maybe a little bit more. So I think we're probably going to call it here pretty soon. But what we're probably going to end up playing around with next time is sort of looking at this, taking a combination of this, and combining it with a combination of something like this. So we'll get into a little bit of shaders, which I have definitely not done, and I'm very curious like what kind of guardrails Rust and the WGPU crate can help or add or give us. Because I haven't really written this code or this syntax before, so it would be nice. I mean, I could write this and I could figure it out, and like doing it in Shader Toy would probably be a pretty decent experience, because you're going to see a very your feedback loop is going to be very short. You make a change, you're going to be able to see it. So like you know, we start out with the vec of this. So like if I do, you know, 0, I don't know that it's actually changing much. I think I'm seeing it all move more this way. I haven't looked at the code enough to understand like what I'm actually changing here. And like we've got signs in here, so like maybe we could really change. Getting a lot more turning. So it'd be nice to have guardrails around this code, and that's also why I'm interested in Naga. But if we do that, we can pull in a WGSL file. I suspect we can probably rip some of this out and see what we can get working just from like a very, like what's the minimum we need to actually get something like to render. And I think that would be helpful for me to get something going. So does this have path image, features, outliers? It would be nice to like be able to do like a little CLI-ish type thing where we can give it a frame number. So like as part of the test, we can have it like run this thing at a specific frame number. Because layout wise, I don't know if we're just computing the first frame, I don't know what that's gonna end up looking like. So yeah, I think that's what we're gonna do next time. We're gonna grab this. We're gonna rip pieces out and see what the minimum portion of this we need to actually run something. Basically take a knife to it. And we're gonna have to do a little bit of like, here we're pulling in framework. We're gonna need to actually do that import. So we're gonna pull this out, chop off pieces that seem like it's something we could chop off for the moment. So we get very much focused on like just the shader or whatever that we're pulling in. And then we're gonna kind of go from there. Once we like get a thing drawing to the screen, then I think we'll start pulling in the shader. And so tying this all back around to Tony's point before, where we were talking about how I've definitely heard that y'all like Tari content, and I appreciate you for that. So tying this back around into how does it fit into the things that we've done with Tori. We can do this and we can write WGPU and we can create a thing that compiles into wasm, and we could actually use that in the web view. So like that's a step. Being able to put it in a Tori app, in a web view in the Tori app would be a step, but that's not necessarily the way to go. And I think potentially like once we get something in the browser and like, you know, if I replace this with that shader, that might be a good place where we can go from there and say, now that I have this thing written in WGPU, can we get it within a tau window? And I think that's going to come back around to some of the content that I'm hoping to do in the near future here, is where we sort of take these lower level pieces within Tori and see if we can just run these low level pieces by themselves and like help you out to sort of gain familiarity on like what this piece actually contains and like what portion of a Tori app is it actually handling. And if we can take this, we should be able to, very similar to how we're doing the eGUI plugin, we should be able to take something like this and put it in a tau window, I believe. So that's how we're gonna loop all the way around. Who knows how, if like I said, I would like to get this content into more of a concise video, because a lot of what we've done today especially has been more experimental, looking at and understanding how these pieces are kind of coming together. And I guess we haven't written any code today. Usually we write some code, but doing programming isn't all about the amount of lines that you write. So who knows how we end up like fitting this all together into like concise videos that are going to be helpful and useful for y'all. But this is sort of like the overarching like theme I believe we're gonna work through for the next couple months, maybe 2-3 months. Sort of like go through all these like low level pieces and see how they're all fitting together. And like some of this is also going to go into one of the newer features of Tori is Tori Mobile. How is that going to change the paradigm? If I mean, some of it is like Tori is doing the work to make it easier to write apps that target all these operating systems / locations. But there's sort of like disparate pieces there. So I think it's definitely helpful for me to understand that, and I hope this is helpful for y'all to dig into it too. So next time, this plus this, and we'll see how far we can get. And we'll see where we put it. I might make a separate repo for it. I'm not quite sure. We'll figure it out. For next week. That is button, but there we go. Next week. Yeah, next week, Tuesday, same time, same place. Thanks for stopping by, y'all. Glad to have you. Thanks for the questions, Tony, and thanks for pointing out those camera audio issues, Brendan. Appreciate you. I'll see you next time. Bye.